I'm Anil Kumar sharing with you today's challenge question, February 7th, 2019. The question here is, find the sum of x, y and z if x minus 1 over y plus 1 over z equals to 58 over 21. Four choices are given to you, 6, 12, 15 and none of them. I'd like you to write your answer in the comments. Write the option A, B, C or D, which you think is correct. And if you have any doubts, post your questions on the video. That'd be great. And thanks for taking interest in yesterday's challenge question. I hope you got it right. Now it is time to provide you with its solution. So the yesterday's question was, ABCD is a cyclic quadrilateral with tangent TA making an angle of 42 degrees with the chord AD. Find the sum of angles ACB, that means ACB, this angle, and the angle ADC if BD is the diameter. Four choices were given to you, right? So let us see how to find solution of this question. Now, a few things to understand. Cyclic quadrilateral means what? So when I say it is a cyclic quadrilateral, that means sum of opposite angles is 180 degrees, right? So we can find angle D from the property of cyclic quadrilaterals. Therefore, the angle ADC will be equal to 180 degrees minus 85 degrees. Correct? So that becomes 95 degrees. Right? So that is angle ADC. Now we need to find sum of these two angles. What is that angle ACB? We'll use the alternate segment theorem. I hope some of you must have watched my video on that. Now here, the alternate segment theorem says that we are talking about tangent line and the chord. The angle given to us is 42 degrees. So whenever we talk about alternate tangent theorem, we should have a triangle inside the circle inscribed. So we can join A to C, so we form a triangle. Now the alternate segment is right there, and therefore the angle which should be 42 degrees is this angle, which is this angle, right? So how do you find it? Well, the thing is like this. This is your segment, and right opposite to this segment is the angle which is same as 42. So this angle here is 42 degrees. In the question, we are interested in finding angle ACB, right? So we want this angle ACB. So what is ACB equals to? Now in any semicircle, the angle formed will be 90 degrees. So we know angle DCB should be equal to 90 degrees since it is in a semicircle, right? Now from the alternate segment theorem, we know angle DCA is equal to 42 degrees. Perfect. So what is angle ACB equals to? So that gives you angle ACB should be equal to 90 degrees, take away 42 degrees. Correct? That gives us 58. So when you take away, it gets 48 degrees, right? 8 take away 4, 48 degrees. So that is 48 degrees. So the sum of these two angles, which is angle ADC plus angle ACB, should be equal to 48 degrees, and ADC is 95, right? So 95 degrees plus 48 degrees. So when you add them, 8 and 5 is 13, and 10 and 4 is 14. So you get 143 degrees. So did I do the calculation right? I think the choices were slightly wrong. So 42 is here. 90 minus 42 is, when you take away, it's 48, right? So, and this angle here is 180 minus 85, so 95. So when you add 95 and 48, you get 8 and 5, 13, 3, and 143. So I'm sorry, the correct answer is not there. It should have been, let me write option E, which is 143 degrees, right? So that is the correct answer. So I hope you understand how we got it. So the alternate segment theorem tells you that the angle which is equal to 42 degrees is that one. And in a semicircle, you form 90 degrees. So the angle ACB is going to be 90 minus 42, which gives you 48 degrees. And 48 degrees plus that angle is 143. So I'm sorry, the choice should have been 143. So the right answer here is 143 degrees. Correct? So that is how you need to solve it. Thanks for watching, and I hope the concept is clear. Now take a shot at our current question, which is based on fractions. Perfect. So this is your question for the day. Thank you and all the best.